This is just a very short note. On Monday, I was able to get a little bit further than I had planned in talking about fixed point methods. I actually managed to talk a little bit about Newton as a fixed point type of method. So I want to give a quick note to that. We're going to assume that everything is nice. We never hit a place where the derivative of f is zero. Newton's method for solving f of x equals 0 is xk plus 1 is the previous x minus the function at the previous x divided by the derivative value there. I can think of this as being a fixed point method. Xk plus 1 is g of xk, where g of xk is just g of x, that is just x minus f of x divided by f prime of x. As with any fixed point method, the convergence is going to be controlled by the derivative of g, which, using the quotient rule, works out to be this quantity. Of course, if you have a fixed point of g, that's the same thing as x equals x minus f of x over f prime of x. Subtract x from both sides. Since we're assuming that f prime at the answer is not 0, this tells us that f of x equals 0. So if a number is a fixed point of g, so that x equals g of x, that is equivalent in our situation to x being a solution of f of x equals 0. If x is a fixed point of g, that is to say a solution of f of x equals 0, then the value of this derivative simplifies considerably because in the numerator this factor is 0. We end up with 1 minus 1 minus 1, that is, and that works out to be 0, which, as we've said, is the perfect situation for a fixed point method. This indicates to me that Newton should be the king of fixed point methods as we know it so far. A more detailed analysis of this will occur in our next meeting.